Now we are going to discuss about the unit 2, that is 8086 system bus structure. So in previous unit we are discussed about 8085 microprocessor. Now I am going to discuss about system bus structure, how the system bus are going to design. So already we have applied the three type of buses, that is data bus, control bus and address bus. So these three types we are already discussed. So in this, how they are going to configure with each other. So this basic idea about the configuration of each bus structures. Now before going to discuss this, now let us discuss the syllabus frame. First one is an 8086 signals. There will be a basic configuration. There are two type of configuration is available. One is a maximum mode of signal, other one is a minimum mode of signal. So there are two type of configuration in the 8086 signals. Then we are going to discuss about the system design, how the system is designing using the 8086 microprocessor. Then afterwards we are going to programming. So there are a lot of programs used in the system bus structure. After that, there are two type of coupled configuration are used. One is a closely coupled configuration, another one is a loosely coupled configuration. Afterwards, we are going to discuss about the advanced processor. So these are the core of the unit 2. Now we discuss about the programming the 8086, how we are able to program. First one, assembly language program plays a vital role for every microprocessing unit. So what is my assembly language program? The program that written with the alphanumeric characters. So the program that held in an alphanumeric character is known as ALP. So what is mnemonics? Mnemonics is the make use of an opcode. So there are two types, opcode and operand. So if a program make use of an opcode, that is known as a mnemonics. So it's nothing but some instruction we are given to the microprocessor. So the ALP has a following fields. It consists of certain fields. First one is a label. Second is an opcode. Third one is an operand, and fourth one is a command. So label defines the particular number for the programming language. Opcode defines what opcode defines. It defines some symbolic natures. Operand defines some instruction, and commands define some what are the instruction you are given that is fetched to the memory location. So these are the four important types we are discussed in the programming 8086. That is ALP, assembly language program. So label, opcode, operand, and comments. So this now we are going to generally discuss about what is label briefly. What is label? It is used to represent the address. So what type of address that instruction has. So it generally defines the address, and also it defines the length. How many characters you are going to discuss. So generally the label have a 6 characters that is used in the instructions. So these are the label definition. Then opcode. Opcode defines, I already tell this, is an instruction. Every instruction consists of an opcode. That is a mnemonics. After the operand consists of an information or data. So these require means it is an operand devices. Then what is a command? Command is a used by the programmer. How the code works that defines the commands. So these are the program we are going to discuss. Let ALP to add the two 8-bit numbers. We are going to add the two 8-bit numbers. In the memory address, first one the 2000 that defines the address, and H defines the memory location. Where the memory location is stored, that is 2000 H. After that we are going to mnemonics, that is an opcode. LDA defines the load the data accumulator. What the data it's able to load. Here we are loading the 2600, that is the address of the particular memory location. So 2600 defines the address. That address load in the LDA value. After that we are moving the data from B to A. That is a register. So these are the types of register. Totally we have 6 type of register. That is B register is moving to the A register. After that we are storing the other data. So we are adding the data and store the result in one particular memory location. So this is the basic idea about the ALP program. Okay, so let us discuss the output. If we are giving the input 2 and 3, it add and give the sum and carry. So this defines the unit 2.